Every month, I have to crawl into this cupboard under my stairs, point a torch at this gas meter, and read off 8 tiny digits to send to my energy supplier. So I did the only reasonable thing. I put a camera in the cupboard and I taught a computer to do it for me. In this video, I'm going to take you the whole way and show you how I built and trained a neural network to segment and extract the digits from my gas meter. I'll show you how it runs live on a tiny Raspberry Pi 4 in the cupboard, how it talks to my home assistant, and finally, the dream, automatically submitting the readings to the gas company so I never have to crawl in there again. If you've ever watched a machine learning video and thought, how does this actually work? This one's for you. Let's get started. Before any machine learning, I needed 3 things: a camera pointed at my meter, a light, and a mountain of photos to learn from. So let's build a thing that gives me 2 of those. All we need is a Raspberry Pi 4 and a camera module 3, and a lot of patience. I wedged it into the cupboard, pointed it at the display, and that's the whole rig. Every 10 minutes a cron job fires. The script takes a photo using the ORPyCam JPEG tool, rotates it 180 degrees, and runs an ROI or region of interest crop, so I'm only grabbing the slice of the frame the meter actually lives in. The photo gets stamped with the date and saved to a folder, and that's it. And then I just let it run for weeks. Every 10 minutes, another photo. Morning light, afternoon glare, the middle of the night, thousands of them, piling up. Because one of the most tedious things about machine learning before we can really do anything meaningful is collecting the data. This shoebox of photos is the single most important ingredient in the whole project. Every so often I OR-sync the whole pile back to my laptop to add to my growing training set. So the hardware is running, the data is rolling in, which leaves the actual hard question. How do we turn a folder of over 3,000 photos into something that can read a number off a screen? Machine learning was a black box to me when I started this, and honestly that's exactly why I picked it. This channel is me taking on things I want to understand and actually building them, instead of just reading about them. So we're going to do this properly from first principles. And by the end, I hope you'll understand every piece of this as well as I do now. And it all starts with one question that sounds simple enough, but absolutely isn't. How does a computer actually see a photo? Here's the first thing I had to get my head around. To a computer, this image, this gas meter, doesn't exist. Not as a picture, not as anything you'd recognize. Let's zoom right in on just these 2 digits and find out what a computer actually has to work with. Because a digital image isn't a picture at all. It's a grid of tiny squares called pixels. Each pixel is really 3 numbers. How much red, how much green, and how much blue, from 0 to 255. So the picture the network actually receives is a grid of these red, green, and blue triplets, and nothing else. No shapes, just numbers. To make that easier to see, let's simplify. Let's collapse each pixel's 3 numbers down to 1, pure brightness. High where the segment glows, and low where it's black. If we lay those values out on a grid and the digit is suddenly right there, hiding in the numbers. So how does a computer find a pattern in a wall of numbers? It slides a little window over. This box is called a filter, or a kernel. Itself is just a tiny grid of numbers. At every position it multiplies each number underneath by the matching number in the kernel. It adds them all up and writes out a single value. If we slide that over the whole image, and we've measured one specific thing everywhere at once, say, is there a sharp edge here? Is there a smooth round bottom here? That sweep produces a new grid called a feature map, which is just a fresh matrix that's bright where the pattern is strong and dark where it's weak. If we stack hundreds of these, each hunting a different pattern, and that growing pile of matrices is what the network truly works on. Not pixels, not pictures, numbers all the way down. So how will our model actually work reading digits off my gas meter? We're not building this completely from scratch. Instead, we'll take a ready-made model called YOLO, or You Only Look Once, and supplement it with our gas meter photos, so it learns my display. For now, the shape of it, a grid of numbers goes into the left, and digit 8, right there, 98% sure, comes out to the right. Everything in between is this map, and I'm going to fly you along it. First step, we squash the crop to a fixed 64 square, 3 color channels deep. That's all the network ever sees, about 1.2 million numbers. As we move to the right, we enter the engine room. It slides hundreds of filters over the grid, each hunting one pattern, like an edge or a corner, and stacks the results. It learns those filters during training. We never handpicked them. Early layers find edges, stack a few, and they combine into curves, then into actual parts of digits. The loop of an 8 or the tail of a 4, and it taps that understanding off of 3 zoom levels, fine for small digits and coarse for big ones. Now the clever part, and it's what makes YOLO a detector, not just a classifier. A classifier takes one crop digit and says 8. Ours throws a grid over the whole image and asks every cell at all 3 zoom levels at once. Is this a digit here? Where exactly? Which one? That's what YOLO means. You only look once. One pass spits out 8,000 guesses. Most are junk, so watch as we clean them up. We bin everything under 25% confidence, where a dozen cells all shout about the same digit, keep the most confident box, and delete the rest. That also settles the odd fight between, say, a 6 or a 9. A meter has 8 digits, so we lock to exactly 8. Sort them left to right, drop the decimal, and there's the reading. One image in, one pass, 8 digits out. I didn't train this model from scratch. As I said before, I couldn't. A network with 3.2 million dials starting from random noise needs millions of images to even learn what an edge looks like. I had a few thousand photos and 1 meter in my cupboard. So I used transfer learning. I started from YOLO V8 Nano, a model already trained on 120,000 everyday photos. It already knows what edges and curves and shapes look like. I just took that knowledge and kept training it on my meter. That's what's called fine-tuning. I don't freeze anything, the whole network keeps learning, but it starts from understands images instead of random noise. And it only has to re-aim that knowledge at one job, find the digits. And it's crazy how good this is. Within a few epochs, barely warmed up, it was already over 90% accurate. The pre-trained model did the heavy lifting, I just pointed at the right job. But before any of that, those photos needed answers. Remember the thousands of photos piling up on the pie at the start? A photo on its own teaches the model nothing. Every single one needs the right reading attached. So I sat down with a little script and flashed every crop on the screen. And I typed the 8 digits I saw, over and over, more than 1,000 times across a few evenings. After throwing out the blurry and half crop ones, I was left with 3,229 clean, fully labeled photos. It auto-saves so I could quit and come back. Riveting television, I know. Here's the one clever bit in the data prep though. I do not crop tightly to display. I add 300 pixels of padding on every side. Why? Because I want the model to learn the digits are somewhere in this wide band, not the digits are exactly at these pixels. That padding is camera drift insurance. The camera can shift a good few centimeters and the model can still find the digits. No recalibration needed. Then I split it. 80% to train on, 20% held back to honestly test whether it's learning or just memorizing. Then I just hit go. Training is basically a loop. The model guesses where the digits are, it checks how wrong it was, and that error is the loss, and nudges at millions of dials a touch to be less wrong next time. It does that over and over, and the loss slides down while accuracy climbs. I let it run for up to 100 passes over the data, but it quietly stops itself the moment it stops getting better. There's no point in grinding away once it's learned the meter. And here's the honest test. I graded on only the 20% I held back, the photos that it's never seen. So I'm measuring whether it's actually learned to read the meters, not whether it's memorized my training pile. And honestly, it's nearly perfect. On photos it had never seen before, it finds every single digit basically every time. For reading a gas meter, you genuinely can't ask for much more than that. So the model's trained on my laptop with a GPU, but the thing that has to run this every 10 minutes is my Pi I drilled into the cupboard right at the start of this video. We built the body, now we have to put the brain in it. So I SCP the model and the script straight over to the Pi. One thing to note, getting the model to actually run on the Raspberry Pi takes a bit of fiddling. It runs in a format called Onyx, which is just a portable Pi-friendly version of the model. I've written up exactly how and the gotchas I hit in the GitHub README, the links below. And it works. At least it mostly does. This was never going to be perfect out of the box. For instance, problem 1, this is the same meter, same digits, morning versus afternoon. The pixels are completely different. My very first attempt tried to solve everything handwritten rules and contrast tricks, and it would work all week and then fall apart on a Tuesday afternoon when the sun hit it just right. That fragile hand engineering pipeline is the entire reason I switched to a detector that just learns the lighting from thousands of examples. Problem 2 was camera drift. Every time I bumped the cupboard door, the camera shifted a hair. With the old tight cropping approach, this was fatal because the crops sliced the wrong pixels. The fix was the 300 pixel padding from earlier. Now drift just doesn't matter. But a number sitting on a Pi isn't of use to me. I want it in my smart home. I run Home Assistant, so I generate an access token, basically a permanent password for my script, and the Pi uses it to send the reading over. I post to a sensor called sensor.gasmeter, and I tag it as a gas meter that only ever counts up. That one tag is what lets Home Assistant Energy Dashboard chart my actual gas use over time. And there it is, a live gas meter card and a full consumption history, built from a camera and a model I trained on my own photos. Genuinely one of my favourite things in my whole Home Assistant dashboard. Okay, the dashboard is great, but the original goal, the thing that started all of this, was never to have to crawl into the cupboard again. And that means reading has to go one step further, to the gas company itself. Here in Ireland, Gas Networks Ireland take readings through an online form, and a web form is just a HTTP post under the hood. I need something called the GPRN number, the meter reading, and a couple of other form fields. So my script submits it in the exact same way it talks to Home Assistant. So here's the full chain, working end to end. Once a reading clears both gates, then on the right day of the month, the Pi fires it straight at the provider and logs the confirmation it gets back. No human needed in the loop. And there it is, submitted, confirmed, and done. A meter that reads itself, sanity checks itself, and files its own returns. So that's the journey. We built a camera into a cupboard and let it pile up thousands of photos. We learned that to a computer, an image is just a wall of numbers. We slid filters over it to find patterns and stacked those into a network. We didn't build it from scratch. We stood on a model that already understood the visual world and fine-tuned it for one job. We put the trained model into a Raspberry Pi, taught it to talk to my smart home, and bolted on guardrails so it hopefully never lies to me. Everything's on GitHub, all the code, the trained scripts, the deployment guide, and a doc that explains every bit of this from first principles properly if you wanted to build your own. The link's in the description. If this was useful or you just enjoyed watching me spend months training a neural network, subscribe and tell me in the comments what I should point the camera at next. Thanks for watching.